is Muhammad Aiman Shazi bin Subo, and welcome to our calculus project. This project shows the mathematical modeling example of real-life problem using calculus concept. This calculus project is done by Azul Hilmi bin Haris, me the presenter, Nur Anis Afika binti Sheikh Shamsuddin, Shahril bin Ahmad, and Umi Kalsum binti Jamal Muhammad. We are from course SEP1. We chose Chapter 3, Application of Derivative, Part B, Optimization, Maximum and Minimum. First, let us define this topic. A local minimum is where the slope changes from going down to going up. So, for a continuous function, the derivative changes from positive to negative. The derivative is going to go through zero. At this global maximum value, the derivative will be zero at that point exactly. Now, let us see our question. The level of nitrogen dioxide in the atmosphere was reported on a certain day in Kelantan are approximated to be A of t equals to 0.003 t to the power of 3, t minus 7 bracket to the power of 4 plus 60.2, and 0 is less than or equal to t, and t is less than or equal to 7, where A of t is measured in Pollutant Standard Index, PSI, and PSI is measured in hours. The initial time corresponds to 7 a.m., which represent as t equals to 0. So the question is, at what time of the day is the air pollution begin to increase and begin to decrease? To solve this question, we need to use the first derivative method, or test. Step 1, we need to find dy dx. Step 2, the dy dx must be equal to 0 to find the critical point. Step 3, we must substitute the critical point. Here is the equation. First, we take A of t and find its derivative. A of t and find its derivative, which is A prime t, which is here. Then A prime t must equal to 0, such as there. So we got 0.09 t to the power of 2, t minus 7 bracket to the power of 4 plus 0.12 t to the power of 3, t minus 7 bracket to the power of 3 equals to 0 here. When this help us to substitute the equation just like shown here. Exactly here. Therefore, the critical value of t are 0, 1, and 7. When t equals to 0, the test fails. However, when t is less than 0, it is maximum at t equals to 1. When t is greater than 0, it is a minimum at t equals to 7. From this, we can conclude that the air pollution begin to increase at 8 a.m. and decrease at 2 a.m. That is all from our presentation, and I hope you understand. Thank you and have a great day.